Okay, so we're going to look at the exam 4 review questions. This is question number 1. My son Toby, mass of 20 kilograms, clearly when he was younger, was standing motionless on his skateboard when his brother threw a ball, which has a mass of 2 kilograms, at him. The velocity of the ball was 1.4 meters per second. Toby was able to catch the ball. What happened to Toby? Justify your answer, meaning did he move or not move? And if Toby remained stationary, discuss why. If he moved, what velocity did he move? All right. Well, I'm going to let you think about that conceptual idea. Does he move or doesn't he move? He has to move. Why does he have to move? Well, there's a collision happening. And when there's a collision, there's conservation of momentum. The system is Toby and the ball. And when we solve the problem, we'll see this. But the system is Toby and the ball. If the ball is moving before that collision, this momentum of the system is non-zero. It has momentum, whether Toby's moving or not. So the system has to have momentum after the collision. If Toby's holding on to that ball, then the system's momentum is made up of those two again together, and they have to be moving together. So, based on conservation of momentum, and the system having momentum before the collision has to have momentum after the collision, Toby and the ball are now one unit. They have to be moving together. So let's solve for how fast Toby, and subsequently the ball, is moving. All right. So we first have to identify our system. This is a conservation of momentum type problem, and we said that system is Toby and the ball. Now with conservation of momentum, we define that initial and final. And we draw those pictures and then identify those pieces that make up momentum. So here's Toby on a skateboard and a ball coming at him. And then there's Toby holding the ball, moving off together. And we're going to predict it's moving to the right because of our conservation principle. All right, so let's look at the two objects within the system. We have the mass of the ball, and that was equal to 2 kilograms. And we have the initial velocity of the ball. Oops. And that is equal to 1.5 meters per second. And we have the mass of Tobes. He's 20 kilograms, of course, when he was much younger. And the initial velocity of Tobes, and that's 0 meters per second. Of course, he would hate that I'm calling him Tobes publicly. Toby. All right, so how about in the final condition? Well, the mass of the ball remains at 2 kilograms. And the final velocity of the ball, well, we don't know. And the mass of Toby remains at 20 kilograms. And the final velocity of Toby, also, we don't know. But what we do know is that they're moving together. So the final velocity of the ball and the final velocity of Toby are equal. So we will call them just final velocity, and that'll help identify our algebra a little bit easier. Okay, so let's look at that conservation idea, which tells us that the initial momentum of the system is equal to the final momentum of the system, which is our initial momentum of the ball plus the initial momentum of Toby. That has to equal the final momentum of the ball plus the final momentum of Toby. Our initial momentum is made up of the mass of the ball times the initial velocity of the ball, and the mass of Toby times the initial velocity of Toby. That's going to give us the mass of the ball times the final velocity, and I'm going to keep that at V final. So I've changed my final velocity of the ball to equal now V final, because there's only one velocity at the end. They stuck together, plus the mass of Toby times Toby's final velocity, which is the same as the ball. All right, so now let's start to look at those variables. The mass of the ball is 2 times 1.5, and we're saying he's to the right, so it's positive. Remember, with momentum, direction matters. Plus the mass of Toby, which is 20, but he's stationary. So that's nice. That term's going to go away. The mass of the ball still is 2, V final. We don't know what it is. Plus the mass of Toby, which is 20, also times that V final. Okay, so we end up with this term going to 0. So we have 2 times 1.5 is going to equal 22 as I pull my V final out times V final. And if we look at 3 divided by 22, we find that V final is equal to 0.14 meters per second. And that's our final velocity of both Toby and the ball. So recognizing we have a collision, recognizing that there's got to be conservation of momentum in a collision, our system, defining what is that initial before the collision and final after the collision, and then applying our conservation principle. Recognizing since the two objects are together, they're moving together, and I can identify that final velocity as a single variable. Good job.